Hey everyone, welcome back to BigBrains chip. Today we are solving boats to save people, a medium level problem using two pointers and a simple greedy idea. We are given the weights of a group of people and weight limit for each boat. Each boat can carry at most two people and their combined weight cannot exceed the limit. We need to find the minimum number of boats required to rescue everyone. For example, with a limit of 3, a person weighing 2 can travel with someone weighing 1, but a person weighing 3 cannot travel with anyone else. We could try different combinations and figure out the best pairing, but we don't need to try every possible combination. There is a greedy observation that tells us exactly who we should consider pairing. First, we sort the people by weight. Now, we have the lightest person on the left and the heaviest person on the right. Now we ask one question. Can the lightest person fit with the heaviest person? Here, 1 plus 3 is 4, which is greater than our limit of 3. So they cannot share a boat. Now here's the important part. The heaviest person weighs 3 and the lightest person weighs 1. And even 1 plus 3 is too heavy. So the heaviest person cannot share a boat with anyone. That means the heaviest person must go alone. We can safely put them in a boat and move the right pointer. Now, our lightest person weighs 1 and our heaviest weighs 2. 1 plus 2 equals the limit. So, they can share a boat. We put both of them in the same boat and move both pointers. Now, only one person remains. So, they need one more boat. So, the entire greedy logic is just two cases. If the lightest and heaviest can fit in together, put them together and move both pointers. If they cannot fit together, the heaviest person has to go alone. So we only move the right pointer. Why can we confidently send the heaviest person alone? Because the lightest person is the smallest possible person. If even the smallest person cannot fit with the heaviest, nobody else can. So there is no better pairing for the heaviest person. Sending them alone is the only possible choice. So after sorting, we start two pointers at both ends. Every iteration uses one boat. If the lightest person can join the heaviest, we move the left pointer. The right pointer always moves because the heaviest person is definitely placed in the boat. That's solving the problem. First, we initially sort the people list. So people dot sort of. And after that, I initialize both the pointers, left and right. So the left points the index 0 and the right points the last value. So people minus 1. And now I'm having the number of boats equals 0. And then a simple while loop. And it checks until the left is less than or equal to right. And now I'm going to be implementing the exact algorithm we discussed. So if people of left plus people of right, if it the summation is less than or equal to the limit, we are going to be incrementing the left, or in any case the right gets decremented. And so the number of boats plus equals 1, and this must work. Return boats. Perfect. Yep, it worked. The key idea is always check whether the lightest person can join the heaviest. If they can, pair them. If they can't, the heaviest has to go alone. And that's chip 12. Don't memorize DSA, recognize it.